Good afternoon, participants. Welcome to the live session of NPTEL MOOC on Engineering Hydrology. This is our second live session. If you are having any doubts related to this particular subject from the lectures which we have covered, you can clarify that. Till now, I haven't received any of the queries from your side. If anybody is having any doubts, you can clear that now. As of now, we have completed almost 4 modules. Now the 5th module is running related to hydrologic analysis. So I think hydrologic analysis, hydrograph, hydrograph, it has started. So is there any doubts related to that? You can clarify that. If there is any query, you can post it there. Different, total we are having 7 modules. Now we are running with our 5th module. First was an introductory module. Second one was started with atmospheric hydrology, and third one subsurface hydrology and surface hydrology, surface water hydrology we have completed. Now we are with the hydrologic analysis. Okay, let me see. Jayanta Krishna, hello. Hi ma'am, how are you? I'm fine, Jayanta. How about you? I hope course is going fine. So hydrologic analysis related to, we have completed some of the lectures now. It is very important topic, hydrograph analysis. This is based on linear system theory we are carrying out. For reaching hydrograph analysis, you need to have idea about the linear system theory. That is why I have devoted one lecture exclusively for linear system theory. In that, different inputs we have seen, and also response functions also we have explained. So those are slightly mathematical, but even without the knowledge of linear system theory, students can perform hydrologic analysis, but you can enjoy the beauty of that topic if you are having that mathematical feel. How that input and response is coming by correlating with the linear system theory, it will be easy to understand the concept. So that particular lecture, second lecture on hydrologic analysis, is very important. So those who are planning for research in water resources, so those slightly on mathematical side, you should have the feel. Otherwise, you won't be able to understand the physical processes clearly and correlate with the analysis part. Last time we had some queries. This time I think not many. So assignment related or any lecture related doubts are there, you can ask now, post it there. Because the topics which presently running is of great importance. Unit hydrograph, S hydrograph, and after that it will be coming. Last time somebody asked me a question related to instantaneous unit hydrograph. That will be coming in the next week, instantaneous unit hydrograph, and how to convert if you are having one hydrograph from one to another. That is very, very important, because when we do analysis such as flooding, majority of the places during monsoon time, it is getting flooded, especially urban cities. So we need to have the hydrologic data and the corresponding analysis to be carried out. For that, you need to have the response of a watershed. Whenever the watershed is experiencing certain amount of rainfall, what will be the response from the watershed? That is what is the phenomenon called flooding, which we are experiencing. So the characteristics of the watershed and also the input to the watershed is very, very important. And the output is represented by means of hydrograph. So hydrograph development is very important. If you are going for a real-time flood forecasting, directly collecting data from rain gauges and carrying out analysis, it will be taking slight delay. So based on the past data, if we can do that, we need to have the understanding about the watershed and also input data. Krishnendu, hi ma'am. Hello Krishnendu. Any doubt? Are you able to follow the lectures properly? So these part we are not covering in this topic. That is irrigation, agriculture related topics we are not included in hydrology. That is regarding Kharif and Rabi season. That is really irrigation related topic is a vast topic. So that should be studied after understanding the concepts related to hydrology. So hydrologic analysis we'll be doing. Mainly subsurface hydrology is very important as far as irrigation related topic is concerned, because we need to have the idea about the subsurface water, moisture present in the ground. So related to that subject is dealing with. So you need to have the idea about basic hydrology. So here, if you are having any doubts related to hydrology course, we can clarify. Next course, I may be planning related to irrigation or groundwater hydrology. So whatever doubts related to this engineering hydrology, please post it. Good afternoon, Irfan. And especially one thing you need to know, students used to make mistakes when do carry out the analysis, flood modeling. We used to collect the daily 24 hours data. Daily data, if you are using, you won't be able to carry out the flood modeling for urban areas and all, because the flooding is mainly due to high intensity, short duration rainfall. So you need to collect the event-based data. Event-based data, after collecting, based on that you need to carry out the analysis. Otherwise, the problem is that for 24 hours data, if you are using, it might have rained only for half an hour that particular day, heavy rain. Due to that, the flooding has occurred. That half an hour rainfall is assumed to be happen for 24 hours. So that way, I have seen some of the students who are doing hydrology related BTech projects, they used to do based on these 24-hour data. So you keep this in your mind that This data which is collected should be of short duration. Aparna P, what time duration rainfall should be? Hello Aparna, your question is what time duration rainfall should be taken to calculate rainfall intensity for an accurate generation of IDF curve? IDF curve is the intensity duration frequency curve. That topic will be coming in the 10th last week. Okay. So that I have clubbed with the hydrologic design when we discuss about design storm. And I'll tell you for answer to your question. IDF intensity duration frequency curve can be derived for any duration. Okay. Starting from 2 minutes, 3 minutes, 5 minutes, 10 minutes, 15 minutes. That way you can derive the IDF curves for different durations. You need to decide which duration IDF curve has to be used for your particular requirement. If it is for urban flooding related study, you have to go for short duration, maybe of 10 minutes or 15 minutes duration IDF curve. Okay, because otherwise the urban cities are getting flooded within 15 to 30 minutes. So intensity will be short duration, high intensity data we need to make use of. So for that, depending on the requirement for which study you are going to make use, according to that, you need to make use of the duration. For example, in the urban areas, for flood modeling in urban areas, you can make use of the 15 minutes rainfall intensity duration frequency curve. I hope it is clear to you, Aparna. Then, ma'am, how to enroll in courses? So this is, I think Jayanta Krishna is asking about enrolling in NPTEL courses. For this course, I think it is ongoing course. Now the enrolling session is over. Now for other courses, all these, I think January to April it is running. Then in the next semester it will be running again. So those dates will be available in the NPTEL site. So according to that, you can enroll in that. Then Bishal Sarkar, hello Bishal, flood analysis of drainage basins. Discuss based on geography approach. Geography approach, in whatever way we are, whatever approach we are using, geography approach, I don't know whether your background is civil engineering or geography. I can tell you, geographically what we collect, we will be collecting the details, data related to the location. That is, you are going to do the flood analysis of a drainage basin. So geomorphological characteristics you need to have. When you collect the drainage map, along with that map, you need to have the elevation. Elevation data you will be getting from the digital elevation model. Digital elevation models also you can generate by using the SRTM data. Freely available data is available. That is, I think, 30-meter resolution data. Based on that, you can derive the details, your contour, elevation related details for the particular drainage basin you are going to carry out the flood analysis. Once the elevation data is available to you, this analysis you will be carrying out by making use of any of the GIS software. From that you will be getting the slope related, slope of the basin at different locations, and talking about the length of the drainage characteristic, that is length of the mainstream, length of the tributaries, drainage density. All those details can be calculated based on the GIS analysis. So first you will be collecting the data of the map of the drainage basin. Map will be chosen and corresponding DEM will be generated, and different steps are there, 5-6 steps are there in GIS to carry out the watershed delineation. So based on that you will get the catchment details. So those are the data which are required related to the basin, even if you are talking on the basis of geography also. If anything specifically you need to, please type it. Then coming to Krishnendu, ma'am, please explain the measurement of rainfall. That is non-recording type and automatic rain gauge recording type. Okay. So this thing I have put the lecture in detail. That is, we were having the recording type and also non-recording type. In recording type, it will be whatever collected data logger is connected to it. So we don't have to bother about that. We need to place it at the location where the measurements need to be done. So that recording gauge will be placed at rooftop. Even we are having our institute at the microclimate station will be having the rain gauges also. So that will be kept on the rooftop or some other location where you are having. You will be choosing the location where this has to be placed. So that will be having a connected to a data logger. That data logger will be collected to the computer. So even if you are sitting at your office or at home, if it is connected to that server, you will get continuously that rainfall data. That is the case with the recording gauges. Majority of our rain gauges are now recording type of rain gauges. Regarding the non-recording one, earlier days we were using the non-recording rain gauges. Non-recording rain gauges will be collecting, as we have seen. Usually the recording will be done, not that measurement is carried out at 8 o'clock. 8 o'clock in the morning, 8 to 8, 24-hour data collection will be done. Indian Meteorological Department timing is like that. So in the case of non-recording thing, recording one continuously, it will be noted. So during the rainy season, we may have to take the measurements, intermediate readings have to be taken, because otherwise the collecting bottles will be fully filled. So then we won't be getting the exact measurement. So with the help of figures I have explained in the lecture, so you please go through those lectures. Still you are not able to understand that, please contact me. Recording and non-recording gauges we have explained in the lecture related to measurement. I think title is measurement of rainfall. So if there is any, still with the figures I have explained that. Please go through that and get connected to me. Still doubt is there. Yes, weighing bucket type, tipping bucket, float or siphon type rain gauges, everything is there in the lecture which is posted. So recording type and also non-recording type. So tipping bucket based on the tipping principle with the figure I have explained, that will be noted. That will be noted according to the according to the data logger placed there. That data logger will be transferring the data to the computer. But non-recording is not like that. Non-recording case you need to measure in between. Otherwise, if it is not a rainy day, you can make use of the daily, that is 24-hour basis, you can make use that. That will be okay. Okay. So Krishnendu, please go through the tipping bucket, siphon type, and all those things which are explained in the case of measurement of rain gauges. Based on that measured data, that data we are collecting from IMD. IMD will be giving us the daily data, and on request we can collect the 15 minutes, 20, 30 minutes, depending on our requirement. For what purpose you are going to carry out the study. Daily data won't be suitable for carrying out the studies related to flood modeling in urban areas. In such cases, you need to go for short interval type of rainfall data. So generally, if you contact online, they will be providing you daily data, but short duration, you have to go to the field and office and collect the data. Okay, so detailed explanation related to that lecture itself is almost, I think, 40 minutes lecture. So Krishnendu, please go through that. So any more doubts? So this is once the topic related to hydrology is clear to you, you can go ahead with the advanced studies. That is, I can tell you, flood modeling and related to that flood forecasting, real-time flood forecasting. All these things can be done as an advanced part of this. But fundamental knowledge you need to have, because when we were discussing about the flood or the runoff, you might have observed it is caused due to the effective rainfall. So we need to separate the base flow from the total rainfall. So that total rainfall will be obtained from the agencies. From that you need to separate the base flow, and that data will be giving the effective rainfall. That effective rainfall has to be utilized for carrying out the study after deducting the abstraction. Okay, so that is why without knowing that, if somebody is going to do flood modeling, without knowing that, directly you are going to carry out the whatever 24 hours data you have collected, carrying out the study. So there should be an interaction with the surface, subsurface, that is abstractions, how much it is taking place. All those things should be taken care. So fundamental knowledge about all these processes, I am covering in this lecture. Different processes related to hydrology we have already completed now. That is up to 4th module. All the processes, important processes related to hydrology we have completed. Now the topic which is ongoing is related to hydrologic analysis. Hydrologic analysis also by next week will be completing. That is very important module. That is hydrologic analysis module is very important. We cannot go that much in depth, advanced way. Whatever basic level requirement is there, that I have covered. And next two modules are related to hydrologic statistics and hydrologic design. So by that we will be finishing the course on engineering hydrology. So this module which we are running now, hydrologic analysis, is seriously look into that. Hydrograph analysis mainly, routing, flow routing, all these things are very important as far as water resources is concerned. Routing is the important principle which is used for river modeling. If you are going to make any river protection work, you need to find out the flow characteristics at the downstream. So those topics should be very, very clear to you. So fundamentally, you should understand that. So please go through those topics. Aparna's question is, phi index and W index we calculate using the equation P minus R by T. The time T is different for phi and W index. What is the difference, ma'am? How we physically measure these two times? Okay. That time we are finding out by making use of the method you might have seen in the phi index method, right? So that time will be different because P minus R, precipitation is there. From that we are finding out the phi index is the representing the abstraction. In the same way, W index also representing the losses from the rainfall. So if we are incorporating only the initial abstractions, I'll tell you that is the surface depression storage and the interception storage. Then the time rainfall which is coming as abstraction will be less, right? If we are incorporating infiltration losses also along with this initial abstraction, more water loss, and the effective rainfall will be less. So the time duration will be different in both cases. So only depending on the abstractions, if you are considering only the initial abstraction, and then the time will be time corresponding to abstraction will be less. If you are talking about the along with the initial abstraction, this infiltration losses also more time for runoff to happen. More time will be taken for the water to get ponded. So that is physical. That is the difference between physically how it is measured. It is not measured. It is calculated. Measuring means that is representing the ponding time, the time when the precipitation occurring, initially infiltration and other losses taking place, and after that when it starts ponding, that difference between these two, that is the time at which it is starting to pond, and also time at which the rainfall started, difference between them is giving the time to ponding. That is approximately representing the time related to abstraction. I hope, Aparna, I have answered to your query. Then next is Irfan Agra, hydrologic design and return interval in the upcoming module. I request you to explain the basics, especially numericals. Definitely, that is a return period and design storm, all these things are very important. Definitely that is the topic which needs to, which will be used later on. Even though you are gaining all these basic understanding of the subject, basic hydrologic processes, all these things, finally by making use of that data, you will be carrying out the hydrologic design and hydrologic analysis. And for that return period in IDF, intensity, duration, frequency curve, all these are very important. Design flood is very important. Those topics will be coming in the last week, 12th week. Definitely, I'll be covering some of the numerical examples which are very, very much important in that section. Now, Vishal Sarkar, hello. Madam, how much this kind of course benefit us? Life, new education policy, like new education policy. Okay, I'll tell you, Vishal, I think you are a civil engineering student, right? So, new education policy, whatever be the education policy, for example, if you are going to do some flood modeling study, okay, education is giving you the foundation. Engineering courses you are doing, you are getting fundamental basic education from the college. But when it is coming to the field, you cannot go bookish way, right? You have to make practical thinking, and based on that, you will be taking decisions. For that, it is very important that you need to have the basic knowledge about the subject. So, whatever new education policy or whatever way education system is changing, the basic concepts are not going to change. That is why the I'm talking about the conceptual subjects. Conventional subjects related to an engineering course is not going to change. Structural analysis, structural design, engineering hydrology, fluid mechanics, these basic concepts are not going to change. If you want to do something in the practical way, the knowledge of this basic topic is very important. So, new education policy is not going to affect in any way. It will be positively coming into you. These basic fundamental knowledge, how it can be utilized in a practical way, that much more idea you will be getting based on that. Okay. So advanced level things or practical way, if you want to implement certain things also, without the basic knowledge, it is not possible. So understand the fundamentals of the particular subject, whatever be the subject, engineering, hydrology or fluid mechanics or geotechnical, any subject, fundamentally you understand that subject, then it will not be difficult in future, practical point of view. So new NEP will be introducing some practical applications into that. Definitely that will be beneficial to you. So any more doubts? I think no more doubts from your side. So finding out after getting the basic understanding of this engineering hydrology, definitely you need to study the course on stochastic hydrology. Stochastic hydrology is very important, and for completing the understanding about these water related topics, agricultural irrigation engineering subject should be studied. Groundwater hydrology, all these we cannot separate from each other. All these go hand in hand. So for those who are planning to go for research, stochastic hydrology part also should be studied. Then comes what is rainfall runoff model? Please describe. Rainfall runoff model, you might have heard about this name everywhere. Rainfall runoff model is the hydrologic model which deals with the study, that is rainfall. Whenever a catchment is experiencing rainfall, it is undergoing different hydrologic processes. Finally, the flow runoff is meeting at the outlet of the catchment. Okay, so you need to quantify how much flow is occurring at the outlet of the catchment based on a certain amount of rainfall. In a basic way, this is the explanation. You are having the watershed. For example, with an example I'll tell. You are going to do the rainfall runoff modeling of a particular catchment. In that catchment, you are having inputs like rainfall, and in the river is there, streams will be there, different tributaries will be joining the river. So you are having the rainfall as input, and so many water bodies, lakes, such structures will be there. Those are the areas where storage is coming into picture. So whenever rainfall is occurring, losses will be taking place. Infiltration, evaporation, evapotranspiration. At the time of rainfall, when we quantify the runoff, majority cases, we will be considering the initial abstractions and infiltration losses. After that, we are getting the effective rainfall. That effective rainfall is coming as the overland flow, and then starts the channel flow, finally meeting at the outlet of the catchment as runoff. So that is, before, once it reaches the outlet as runoff, that we are measuring as the stream flow. So rainfall runoff modeling is dealing with, it's a general term used for any of the model related to flood modeling, river flow modeling, all these. So in this rainfall runoff models, when we talk about, it is having a database. Database is related to inflow, rainfall, and losses. And database includes the losses data also. Evaporation data you will be collecting. Then infiltration data you cannot collect. You will be having the soil data. Based on that, you will be calculating infiltration by making use of any of the equations which you have studied. So out of that, you can quantify the effective rainfall. Effective rainfall will be converted to the runoff overland flow finally meeting at the outlet. So this is the rainfall runoff process. And after doing this rainfall runoff modeling, you will be getting idea about how much will be the water depth at different locations, and what will be the how long it will be flooded. And in the case of a river flow, whether river flooding will occur at the downstream location, or how much will be the stream flow at the downstream location. All these things can be quantified. So you have to choose a suitable rainfall runoff model depending on the area of work which you are planning to do. If it is related to a flooding due to rainfall in a particular area, so many freely available softwares are there. You just have to be very careful in collecting the data. Those data will be fed into the model. Based on that, you can find out whether river flooding is there or a particular location is getting flooded, how long it will be flooded, how much flood depth will be there, whether you will be able to travel to that location, or roads or important structures will be getting flooded. All these details will be obtained after carrying out rainfall runoff modeling. What is its application? I think I have mentioned along with this, that is rainfall runoff models can be used for studying the river flow. River flow modeling has to be carried out for finding out the velocity flow at the downstream location and at the required location where you are planning to construct a hydraulic structure, or river bank protection you are planning. For bank protection structure to be built, you need to have the velocity and flow at that particular location. So for that, you will be making use of the river flow modeling. And for the urban flooding study, rainfall runoff modeling will be stormwater modeling system will be utilized. All these are working based on the same principle of rainfall runoff concept. Ma'am, why IITs prefer foreign author textbooks? Are Indian authors less standard for IIT people? Not at all, Jayant. This Indian author, I am referring so many Indian authored books. If you have gone through my lectures, you might have seen Indian author textbooks are there. Ventichow textbook is there. Applied Hydrology by Ventichow and others, one foreign textbook is there. And Subramanya textbook I am referring. Engineering Hydrology by Professor Subramanya. Then Engineering Hydrology by Professor Srivastava and Jain. That textbook I am referring. And when you check my reference list, Indian author textbooks are also there. We Indians are not bad. We are having very good textbooks by Indian authored books. That way we never tell that Indian books are not good. Indian books are also good, along with, at par with foreign authored textbooks. But we should have the flavor of all the books, Indian authors and also foreign authors. So that is the only thing. Other than that, when you please look into the reference list of my subject, Engineering Hydrology, you can see so many Indian authors named there. Okay, in Himalayan area, which model is preferred? Actually, we are talking about the Himalayan areas, means that is those areas are having steep slope. All these areas, the slope is very high. In that case, Hortonian overland flow modeling won't be working. The principle is different. Saturation overland flow is occurring, and also the snowmelt cases are predominant. So snowmelt cases studies are dealt by certain models. Snowmelt analysis can be done by making use of certain hydrologic models are there. Even I think HECRAS is having a module corresponding to snowmelt runoff calculation. So exactly, I haven't done any studies related to this hydrologic modeling. People are that is for the particular area, Himalayan region and all. Hydrologic modeling people are carrying out by making use of SWAT model, but it is hydrologic model only, not hydraulic modeling. Hydraulic modeling, you can make use of HECRAS. Snowmelt part, how much it is there, I haven't explored that part. but definitely the concept is different, because when we talk about the Hortonian overland flow and the saturation overland flow difference, you might have seen in the case of when we were discussing about the overland flow. Majority of the commercial softwares are dealing with the Hortonian overland flow, not the saturation overland flow. And the regions normality is occurring, so that module has to be separately considered. So common models which we are dealing with, that won't be incorporating that. So glacial snowmelt topic is entirely different. Along with that, we can club it, but that is entirely different when we talk about the modeling of those regions. Any more doubts? But whenever you are talking this subject, if still I think students are having a confusion that what is the application coming. So I'm repeating again. So many applications are there in the field. Even if you are we cannot consider it as a separate entity. All the civil engineering topics, structural, bridge design, and geotechnical related, and river flow modeling. If you are going to construct a bridge without considering the river flow analysis, can we do the construction there? So initially we need to have the idea about river flow modeling. So you need to have as a basic civil engineer, you need to have flavor of all these subjects. And sometimes you may have to take decisions related to structural side, geotechnical side, and road construction also. Several hydraulic structures are coming, culvert design is coming, all those things, and proper road design, proper design will be happening only if there is no flooding. So all these things have to go hand in hand, then only finally a better solution we will be getting. So that is why whatever subjects are there in civil engineering, it should be clearly connected to each other. How to calculate, Kumar Abhishek, how to calculate scouring depth. Scour depth calculation, according to IS code, we are making use of Lacey's formula. Lacey's formula also, when we check it, even if it is a bridge scour, then from by comparing all those values, slightly at a higher overestimated way, but we are following, we are making use of Lacey's equation for calculation of scour depth. But that scour depth topic, that erosion scour depth part is not coming under this particular course syllabus. Lacey's concepts, you will get any of the water resources textbook, Lacey's equation. And but we are constructing, we are calculating scour depth means you have to follow IS code, where we are making use of this Lacey's formula only. In literature, you can get so many equations for calculation of that. And this for construction, according to Indian conditions, you have to follow the IS code. Jayant Krishna, other than GATE, how can we get into IITG? If you are talking about MTech, GATE, through GATE only. Engineering students will be getting admission through GATE. PhD students, after completing MTech, they will be, they have to go undergo certain exams sometimes, or sometimes interview only. That individual institute will be conducting. According to that, initial shortlisting will be based on the examination conducted by IITs, and then second shortlisting based on interviews. But MTech getting into IIT, you need to have GATE score with scholarship. For studying MTech with scholarship, you need to have valid GATE score. So any more queries? 3:45 already. We are having 15 minutes more. Kumar Abhishek, Kumar Abhishek question is, any calculation sheet is available as per IS course? Calculation sheet is not there, Abhishek. Those rules we have to follow. It's a simple formula. Based on that, we need to calculate that depending on the data. It depends on the data of the field, particular location where you are going to find the scour depth, particle diameter, all those details you need to collect, and based on that you need to calculate. That's not as complicated as our rainfall runoff modeling and all. It's an empirical formula, just substituting in the formula and getting the value, taking the value. May you share the as such calculation sheet is not there. Any more questions? So I think we'll be having one more session, live session. So that time, if there is any doubt, please come up with that, or you can post it in our Gmail group. We usually we are very prompt in replying to the queries. In case any of the queries missed out, please send a reminder. We usually won't miss. We 3-4 are looking into email every day, and we reply to all the queries. So in case you are facing any doubt related to Aparna or Krishnendu, somebody asked for regarding the measurement thing, measurement related, go through that lecture, and still you are facing any issue related to measurement, just post the doubt, I'll clear it, okay? How to calculate waterway? Waterway, you are talking about the bridge point of view. That is proper data needs to be collected, and some nowadays water, and also we need to do the field survey for that. After that we can calculate that. Those things are coming under hydraulics, not coming under hydrology course. Hydraulics and hydraulic engineering, hydraulic structures, there we are teaching related to calculation of waterway. Yes, bridge cross section details are required, and based on that, for analysis we need to divide it into left over bank, right over bank, and the channel reach, all those things. In detail it is coming under hydraulics. That modeling can be done by those who are writing the code. It is fine, they can make their own code. Otherwise, freely available software is there, HECRAS. You can calculate the bridge scour in that by making use of different formula, and cross section in that river modeling is also there. There is a module for calculation of bridge scour in that. So making use of that software also you can calculate, but whatever software you are using, fundamental concept should be clear to you. Then make use of the software with the available data. So definitely in the coming lectures, I think three more, now it is 8th week running. Monday onwards, 9th week will be starting. So 9th week will 9, 10 will be completing hydrologic analysis. And after that, as some of you asked, this hydrologic design and statistics will be incorporating the topics related to return period, IDF, all these things. So by that, we'll be finishing all the topics related to this particular subject. So hydrograph related topics, unit hydrograph, step hydrograph, instantaneous unit hydrograph, all those things, please be thorough with that. Understand the concepts clearly. Those who are planning for higher study or whatever be the plan in future, hydrology related, basic civil engineers should have fundamental knowledge about these topics. Ma'am, can South people can sustain in North? Definitely, if there is a will, there is a way. Anybody, wherever, if you really want, you will sustain. It's not a difficult thing. Anyway, higher studies, you are planning for studying that is the main aim. So if that is the thing which you are keeping in your mind, wherever you are, you can study. Not an issue. So any advanced level way clearing about this subject, you can post the questions there, because in the lecture all those things won't be covered. It will be difficult because carrying out within the limited time, engineering hydrology is a very vast subject, and whatever important topics are there, that I am trying to cover. So slightly advanced level, if you are having certain query, definitely post it in the Gmail group. We will try to clear that. I'm interested in Kumar Abhishek. I'm interested in flood modeling. Which model is easy? Okay. Easy point of view, don't look at it. What is your aim? What kind of study you are planning to? So according to that, you choose the model. Okay. So if you are a BTech student, I am telling you, freely available models are there. That if you are going to study if you are going to carry out the study for an urban area, SWMM is a freely available model. Okay, SWMM can be utilized for carrying out the flood modeling in the urbanized area. And along with that, if you are incorporating HECRAS and HECHMS, you will get the flood inundation depth, flood inundation extent, all these complete modeling will be over. So all these softwares, HECRAS, HECHMS, SWMM, all these are freely available. You can freely download. Now coming to the modeling, these models will give accurate results. Now coming to the data related part. Data also, GIS software is also freely available to you. QGIS you can download and install. And watershed related, watershed delineation, all those parts can be done by using QGIS. Other paid softwares are there. If you are having access to that, you can make use of ArcGIS. Otherwise, QGIS is a good option. So because students' point of view, they won't be having access to the paid software. That is why I'm talking from your side. So QGIS can be utilized, and watershed delineation, all those things, if you carry out by using QGIS, that data exported into SWMM, HECRAS, HECHMS. So complete modeling can be, flood modeling can be done. These softwares are very easy to use. Only you need to spend some time with the data exercise which they are providing, examples which they are providing along with the software. So please try to do that, and then slowly you will be able to understand, and for within 2-3 months you will be able to carry out the flood modeling study for a particular area. But for getting accurate results, you need to have the accurate input data. So data collection should be carefully done. Otherwise, for carrying out these type of studies, you are having so many freely available satellite data. Those data can be used. Rainfall data also freely available, daily data. Again, I am repeating, short interval data you have to go to the agencies and collect. Otherwise, gridded freely available data is there from IMG that can be utilized, and then carry out the watershed delineation using GIS and analysis using any of these software. Okay, I think now the doubts which you have posted, I have already cleared. And any more doubts, you can send email to me. Because here we are having limited time, we cannot go beyond certain time for explanation. So detailed explanation related to engineering hydrology course and the lecture, please post in the Gmail group. So I think we can wind up now. No more questions. If still questions are there, please send to our Gmail group, and go through the lectures which we will be posting in the coming week. Those are important lectures, very much required for any studies related to water resources. Please go through that seriously, and all the best. So I think 2 more minutes only. Thank you, Aparna. So I don't know whether I have answered to you properly. If still doubt is there, you can post the question there in Gmail. Okay, I think our time is going to end. It's already 3:58. Thank you very much. So I'm going to wind up the session now. Please, again, I am requesting you, please carefully understand the concepts related to hydrographs and the other topics which will be coming in the coming week. Okay? Okay then. Bye-bye. So